Hi, Math 131, Exam 3. Number 10, this is an equation. It has an equal sign, so we can eliminate fractions by multiplying both sides of the equal sign by the LCD. You're not allowed to do that to get rid of fractions if there is no equal sign. You have to have that equal sign before you can get rid of the fractions. So, okay, the LCD, let's see, first we'll factor. Yes, we can factor on the right side of the equal sign. We get n plus 5 times n minus 5. Okay, now the LCD for these three fractions is n plus 5 times n minus 5. So we're going to do step 2, get rid of the fractions by multiplying each of the fractions by the LCD on the top, right? Here it is, n plus 5 times n minus 5, n plus 5 times n minus 5. Here's the equal sign, n plus 5 times n minus 5. Simplify. No more fractions. 6 parenthesis n minus 5 minus 3 parenthesis n plus 5 equals the other side 3. Distribute the multiplication to get rid of the parentheses. Combine like terms. We're down to 3n minus 45 equals 3. Now get n by itself. We get n equals 48 over 3, which is 16. Then you check your answer to make sure it doesn't give you a zero denominator. Make sure it doesn't cause a zero in the bottom of the original fractions. And it's good. Your answer is n equals 16. Okay, number 11 says to solve 1 over 20x minus 1 over 5 equals 5 over 8x plus 3 over 8. Again, this is an equation. It has an equal sign, so we can get rid of the fractions by multiplying both sides by the LCD of all the little fractions. And I worked out the LCD here. It's 40 times x. So I multiply the first fraction times 40x minus the second fraction times 40x equals the first fraction on the other side of this equal sign by 40x plus the second fraction on the right side by 40x. Factor cancel, no more fractions. 2 minus 8x equals 25 plus 15x. Now we just need to solve for x. So let's work on isolating x terms, divide both sides by the coefficient, x equals -1, and then you can check your answer by plugging it back in. You can see it doesn't give you a zero denominator in your original question, and if you plug it back in carefully, you'll see that it makes both sides equal. Moving on to number 12. Solve the rational inequality. See, it has an inequality sign right there. You must use a sign graph. Graph the solution set and write the answer in interval notation. Okay, being less than or equal to 0 means that this side, x minus 8 over x plus 5, is negative or 0. Okay. Step 1, we're going to partition a number line using the real roots of the top and the bottom. So set the top equal to 0, set the bottom equal to 0, solve. You get x equal 8, x equal -5. Those are the numbers you're going to use to partition your number line. Okay, then we're going to find the sign of the entire fraction, x minus 8 over x plus 5, in each of the regions. Okay, let's see, I'm trying to move that up a little bit. All right, so here's my -5, here's my 8. I've got everything busted up into 3 regions. Here's my fraction, and I'm going to choose a test point in each of the 3 regions to figure out the positive or negativeness of the top and the bottom of the fraction. Then divide them to get a plus here, divide them to get a minus here, divide them to get a plus here. Now, step 3, we're going to shade the regions that make the fraction negative because of what we said at the very top. So that means we're just going to shade the middle region, right? And then, because the inequality came with an equal portion, we're going to use boxy brackets on any of the endpoints that do not make a zero denominator. Okay, so I am going to use the endpoint 8, but I cannot use -5 because -5 would make the bottom of the original fraction negative. I mean 0. It would make it 0. So my answer is this graph, and I'd write it in interval form, open parenthesis, from -5 to 8 boxy bracket. Number 13, solve the problem. A cyclist bikes a constant speed of 22 miles. Okay, so that's going to be always 22 miles is his rate of speed. We call that R. He then returns home at the same speed. R is always 22. but he takes a different route. His return trip takes 1 hour longer, and it is 27 miles. So 22 miles going out, away, and 27 miles coming back. Okay, let r be the rate of speed away. It's also the rate of speed back. Let t equal the time away, and they said it takes 1 hour longer to come back, so t plus 1 is the time back. Remember the formula, distance equals rate times time, and create a table. We have a row for the away trip. We have a row for the back trip. D, distance equals rate of speed times time. Now, going away, the distance he traveled was 22 miles, and that is equal to the rate of speed, which we'll call r, times t. Okay, then coming back, he drove 27 miles. That's equal to the rate of speed times t plus 1. Okay, now his rate of speed, we don't know his rate of speed. We just know that it was constant. We know that his distance was 22 going away, and it was 27 coming back. That's what these are. The rate of speed we don't know, and we only know about the time, that the time away is t, but the time back is t plus 1. So we're able to form two equations, A and B. All right, so what we're going to do is solve the first equation, A, for one of the variables. We'll solve it for t. Once we have that, we're going to take it, and we get t, this is equation A, t equals 22 over r. We solve for t. Now, next step 3, we're going to substitute that result into equation B. 27 equals r times t plus 1, but in place of t, we use the 22 over r that we got here. Now we're going to get rid of the parentheses by distributing multiplication. This cancels. 27 equals 22 plus r, so r is equal to 5. And that's what they asked us to find, the speed r. It's equal to 5. And finally, we have question number 14, extra credit. A painter can finish painting a house in 5 hours. Her assistant takes 7 hours to finish the same job. How long would it take for them to complete the job if they were working together? Round your answer to the nearest tenth. Answer in decimal form if possible. Let t equal the time working together. So here's the rational thought. The amount of the whole job that the painter completes in 1 hour plus the amount that the helper completes in 1 hour has to equal the amount they complete together in 1 hour. So the painter takes 5 hours to do the whole job, so in 1 hour she does 1/5 of the job. Bring down the plus. The helper does the whole job in 7 hours, so in 1 hour the helper does 1/7 of the job. Bring down the equal sign. It takes t hours to work together and do the whole job, so in 1 hour they complete 1 over t of the whole job. Now, this is a fraction, equation with fractions. We want to solve for t, so get rid of fractions. It has an equal sign, so we can multiply both sides by the LCD. The least common denominator in this case is 35t. So I multiply both sides of each term on both sides of the equal sign by 35t, 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 factor cancel, and I have no more fractions. I have 7t plus 5t equals 35. You have to show that work. You have to show how you got rid of the fractions. Okay, combine like terms on the left side. You get 12t equals 35, and divide both sides by the coefficient 12. Now we go to the side, and we have to divide 35 divided by 12, and then we put a decimal, work on past the 10th location so we can round. This is a 10th location. There's a 1 after that, so we're rounding down to 2.9 hours.